So this one is June 2023, Unit 6 paper. Last we discussed was question 1. Today we'll do question 2. So in this question, two organic compounds are there. One is X, another one is Y. And they're both colorless. They don't have the color. Each compound contains only one functional group is there in each compound. Few drops of deionized water are added to a beaker containing X, and a misty fumes are observed. So whenever a water is added and a misty fume, so what this give an indication, because look, for example, if we have any acyl chloride is there and we add water H2O, so OH will take position of a Cl and it will produce C double bonded with O and OH plus HCl. So this HCl is responsible for a misty fume. A drop of concentrated ammonia on the tip of a glass rod is placed, the misty fumes, white smoke is formed. Why there is a white smoke? Because this HCl which is released combined with ammonia and it will produce ammonium chloride. That is why it will give white fumes. Deduce the functional group of X. So what is the functional group of X? And it's of 3 marks. So you have to justify also. So which functional group is present in X? The functional group which is present in X, that is C double bonded with O and Cl, which is acyl chloride. And how we deduce? We deduce first when we add water. So when we add water, it causes hydrolysis. Hydrolysis means breakdown of a substance by the action of a water. That is called hydrolysis. So because of the hydrolysis, it gives HCl. And this HCl which is given off reacted with ammonia to give ammonium chloride. So X contains acyl chloride. X is acyl chloride. State the precaution that you would take to minimize the risk of carrying out this test on a misty fume. Assume gloves, safety goggles, and lab coat were worn. So because HCl, whenever a gas is toxic or corrosive, so what we should use, we should always use a fume cover, or a fume hood can also be used. So whenever toxic gases are there, so we should always use the fume cupboard. Carbon 13 NMR has two peaks. What does it mean? Carbon 13 NMR has two peaks. It means like it has two different carbon environments are there. And two different carbon environments are there. So we have to display a formula, draw display. So this, we already know that there is a C double bonded with O and Cl. This is one carbon. So means there should be another carbon and the two carbons have different environments. So this carbon 13 environment is different from this carbon 13 because their surroundings are different. So when the number of the peaks shows how many carbon environments are. Carbon 13 peak shows how many carbon environments are there. If carbon 12, why carbon 12 does not give the peak? Because carbon 12 has even number like 6 proton and 6 electrons. So they cancel out the magnetic effect of each other. But carbon 13, odd number is there. So overall net magnetic field is there. That's why it will show results in the nuclear magnetic resonance. The mass spectrum of Y is shown. This is a mass spectrum of Y. Bubbles are observed when aqueous sodium. So this is about the Y. Bubbles are observed when aqueous sodium hydrogen carbonate is added to Y. So if we add a metal carbonate, so what this given indication, this given and it give a bubble. So this given an indication that there must be a carboxylic acid. Deduce a formula, find responsible for peak at 45. So this, which molecule is responsible for giving a peak at 45? This is actually a confirmation that because there's a carboxylic acid, so carboxylic acid is C double bonded with O and H. And always a positive ion in a mass spectrometer, we have always have the positive ions Negative ions does not show this, like, because we target the molecule by bombarding the molecule by the electron, so it will knock out the electron, so it will always form a cation. So what is the total mass of this ion? Because carbon is 12 plus oxygen is 16 multiplied by 2 plus hydrogen is 1. So 12 plus 32 makes 44 plus 1, 45. So the 45 is actually a peak due to C. So this confirmed that the ion which is present is COOH. But because you mention ion, so it's important that you write the charge. If you don't write the charge, you write only COH, then it is you will not score the marks. If you put a bond here, then also you will lose the mark. Why? Because this bond is broken, so there is no bond here. So you're not supposed to show the bond, just only COH and a positive charge. Is it clear till this point? Next is draw the structural formula of Y. So how to draw the structural formula of Y? Look, first we work out the molecular mass of the Y. This is 74. So molecular mass is 74. And out of 74, 45 is due to COOH. So for 74 minus 45, this will use to work out how many carbon and hydrogen are there. So this will give us 29. So 29 means C2H5 will be there. Means with this thing, what is attached? It is attached C2H5 because C2H5 is 29 and this is 45. So when we add them, we get 74. So we have to deduce the formula, draw the structural formulas. In a structural formula, you don't have to show all the bonds. In a structural formula, you can simply write, like I can write C2H5, COOH. Or I can also write CH3, CH2, COH. That is also the structural formula. So it's actually a propanoic acid. Next is both X and Y can produce ester. So X is, name the compound. So first we work out X. What was X? It was CH3, C double bonded with O and Cl, which was ethonyl chloride. And what is Y? Y is a propanoic acid, which is CH3, CH2, COH. So when they will form the ester, this whole group because for formation of an ester, like this carbon chain is there. So this is ethonyl chloride. And this is propanoic acid. So first name is always from alcohol or, so this will be ethyl. And the second name is from the carboxylic acid, so it will be propanoid. So this will form ethyl propanoid. So name a compound that would react with both X and Y to form ester. Okay, so we want to, because to form an ester, this is ethonyl chloride is there. This is ethonyl chloride, and this is, so what we can do, we can react, we prefer not reaction between them, sorry. We have ethonyl chloride is there, and we have a carboxylic acid, which is a propanoic acid, CH3, CH2, COH. So with what we can react with them to form an ester? So we can react with any alcohol is there, because if we react alcohol with this, it will form an ester. Alcohol with this, it will also form an ester. But the advantage of using ethonyl chloride, the reaction will be irreversible. Here reaction will be reversible. So name a compound So that would form ethyl ester. So ethyl ester, which alcohol we should use? So we should use ethanol. Ethanol react with both of them to form ethyl esters. Student prepare an ester using X and a suitable compound. Explain why student added aqueous sodium hydrogen carbonate to a reaction mixture to allow the presence of an ester to be detected. So first, when a student X like substance X with alcohol, it will form an ester. And what is the reason for using a sodium hydrogen carbonate? Because like we were having CH3, C double bonded with O and Cl. And we add an alcohol, like example C2H5OH. So this will take position of a Cl, this whole with O. So this will form an ester, which is CH3, C double bonded with O, and O C2H5 plus HCl. So HCl is there. What is the purpose of adding a sodium hydrogen carbonate? So purpose of adding sodium hydrogen carbonate is to remove acid. We like neutralize the acid. And why we should remove neutralize the acid? Because the reason is that acid is also having a smell and ester is also having a smell. So the smell of the acid may mask the smell of an ester, right? Because they both have smells. Both compounds, acids have a smell, esters also have smell. So when two compounds are mixed with each other and they both have the smell, so the smell mix with, like there's a smell of an acid might mix with the smell of ester, or smell of an acid mask the smell of an ester. That's why we should remove the acid. And how we remove the acid? By adding sodium hydrogen carbonate. Both X and Y reacted with ammonia, form different products, identify by name or a formula. So first, if we have X was ethonyl chloride and it reacted with ammonia. So NH2 will come, so this will be CH3, C double bonded with O, NH2. This is organic product is there, plus HCl. So this is called ethanamide and hydrochloric acid, hydrogen chloride. But product with Y, when the carboxylic acid react, because Y is a carboxylic acid, which is a propanoic acid. So if you have CH3, CH2, COOH plus ammonia is there. This is acid-base reaction. So this will form a salt. So this will form CH3, CH2, COO. Actually, this will donate proton. Ammonia will accept protons. So it will form NH4 plus. This will be the salt. And the name of this salt, this will be ammonium propanoate. Is it clear, this one? Okay. So unit 6, as I mentioned, better you get in unit 6 when you solve different, like more past papers.